Hello, everyone. I'm Karën Fort, and as Sylvain has introduced me, we will present a talk on the reproducibility of NLP experiments in terms of their carbon footprint. So, first of all, the information communication technologies cause significant environmental damages, and they are expected to increase. In 2020, they were estimated to account for around 4% of the global electricity consumption and between 2 and 4% of global greenhouse gas emission. And there has been at least a 5% increase in emissions since 2015. And as we all know, we need to reduce the global emissions, also the ICT sector. In the case of machine learning methods, we've also seen an exponential growth in the energy requirements and compute requirements to train state-of-the-art models. And machine learning activities consume significant amounts of energy. So, for instance, at Google, it amounts or 10 to 15% of the energy consumption of the whole company. And it has been shown that there are important greenhouse gas emissions that are induced by the energy consumption required to train large language models on the order of magnitude of 500 tons of CO2 equivalents to train GPT-3 model once, for instance. Since the similar work by Struble and colleagues showing the importance of deep learning impacts of NLP in particular, there has been a call for a green AI research that evaluates model not only in terms of its accuracy, so in the quality of the models in some sense, but also on its efficacy of the amounts of energy of environmental damages we required to produce the model. And green AI is now a research field, and there has been a number of tools that were developed to evaluate the model's carbon footprints. There are two main families of tools which kind of implement the same formula but gather information from different sources. There are measuring tools that pull real-time information from the registries on the direct consumption. And there are estimation tools where you can run it whenever you want. You just plug in the information on your hardware on the time you run your experiments, etc., and you get a number. You can use them before, after, even when the experiment is running, whenever you want. And if we want to reuse and compare the environmental assessments we make, they need to be reproducible. There are different levels of reproducibilities that are possible. We can hope to reproduce to the level of the same value. For measures, it will not be possible since measures are not deterministic, especially in terms of energy consumption of a process. You never have the same exact scheduling in your computer. You can reproduce to the level of the results, so having close results. And when you cannot have a reproducibility to the level of the results, a lower level of reproducibility is only when you are able to reproduce the same conclusions, but not the same results. And here we are interested in how can we reproduce the results of NLP environmental footprint assessments. So in this work, we studied 5 NLP studies. So one on the carbon footprint of name recognition in French, one on French and English language spoken understanding, one on French spoken language understanding, one on the carbon footprint of models, and one of the carbon footprint of the Bloom model. And we chose these studies because, first of all, they include an assessment of the carbon footprint of the experiments, and also they either provide enough information that we could try and replicate their results, or they give us, or we were able to contact the authors if we needed supplementary information. One of the challenges is that all the studies use different tools. Some use the measuring tools, some use the estimation tools, and they also have different scopes. So while all the evaluations account for the energy consumption, the evaluation of the Bloom model, so the study by Journée and colleagues, also account for the production of the hardware. And we wanted to be able to use the same tool to reproduce the results from all of these studies. For that, we used a tool that we developed, which is called MLCA. It evaluates the impacts over the production and use phase of the hardware. And the estimations for the hardware production are based on the data and methodology of the Boa Vista Association. And also on the only study that we know of that accounts for graphics card production in a life cycle assessment, and it assesses the usage of the energy consumption with the same methodology as the kernel algorithm tools. So it's an estimation tool, and what we can say first is that reproducibility was much more complex than what we expected, because for all the studies we needed to gather additional information beyond the information that was available in the manuscripts. So for instance, we might have information that the experiment was conducted on one specific data center, but we did not know the specific hardware in the data center. So we needed to use the public information on the data center to cross-reference. Or we did not have the information. In 3 of the 5 studies, we needed to contact the authors to get supplementary information on the hardware configuration they used. And another thing is that the processing units usage, so whether the graphics card was used at full potential, full power all of the time, or for 50% or etc., was generally not reported. So we needed to choose a value. We chose the maximum value possible. And this process also revealed some incoherence and inconsistencies in the manuscripts. So for instance, in one of the papers, we spotted assessments that were multiple orders of magnitude higher than what we could expect. And after pointing this out to the authors, they conducted new experiments that we were then able to reproduce, and also some inconsistencies. So, for instance, there was a problem in one of the manuscripts with the carbon intensity, so the factor that you use to convert the energy consumption to the carbon footprint. What amount of CO2 emissions per kilowatt-hour, and it was not constant. So sometimes it was the carbon footprint of the electricity mix of France, sometimes it was another country, and while all the experiments were conducted in the same place. So this should have been constant, and this should have matched the carbon footprint or the carbon intensity of the French electricity grid. And one possible explanation for that is that the measurement tools, they need to gather information on your location. And sometimes if you use a secure connection, for instance, they might not be able to retrieve your location properly, and they will use an incorrect factor for that. And you might miss that they did not use the factor that you wanted. On a more general level, we were able to reproduce the results of 3 of the 5 studies, and the 2 studies where we showed problems, we were not able to reproduce the results, but only the conclusion. So that the fact that training a model for longer emits more carbon. And we have a little bit higher estimates than the assessments in the manuscript. So this is first of all due to the fact that we used an estimation tool, and estimation tools tend to provide higher results than the measurement tools. And also due to the fact that we used an overestimation of the use rates that was not reported. If we take a closer look on the Bloom language model assessments, so the paper by Journée and colleagues, we can see that for the embodied impacts, which are the impacts of the hardware production that we can attribute to the specific training, we can see that we have close results, but a little bit higher. And this is because we have a different methodology for assessing the impacts of producing graphics card. And since there is no publicly available data, it's complicated to have precise information. On the dynamic energy consumption, so the energy of the hardware that's running the experiment, we are very close, a little bit underestimating, but it's mostly due to rounding errors. And on the infrastructure consumption, so the consumption of the data center and the node of the data centers that are required to do the scheduling, to cool the hardware, etc. We have a little bit higher results than the results presented in the manuscript, but this is because the results presented in the manuscript did not account for the time when the nodes are on, but are not running your job. And why do we account for that? It's that for your job to be able to run, we need to have the data center that's on and loaded. So to be able to have the scheduling properly done, we also need to account for that. And this explains the difference in the results we have. So what we can say is that reproducibility is a difficult endeavor, and this is not specific to the environmental assessment, but it also holds for environmental assessments. If you do not plan your studies to be reproducible, it will be really hard to do it a posteriori. You not have all the information that you need, and you might have a hard time getting back all this information. It requires special efforts if you want it to be effective. And even when you are trying to be reproducible, problems may arise. So, for instance, in a study that we did not comment because it was not an NLP study, we were able to, it was really easier to reproduce the results because of the supplementary material and all the efforts they dedicated to it. Still, in this case, there was a copying error in the supplementary material leading to the erasure of some parameters of some experiments that we then needed to approximate. And there are also lots of challenges for the environmental assessment of natural language processing. So there's a lack of data availability. So for instance, does the tool have data on my specific hardware? If I use an A100, does the estimation tool have information on the energy consumption of this specific GPU? There are lots of uncertainties over the whole chain. So over the production, we don't really have certain information, especially since there is no available public data by the manufacturer. And even in the use phase, as we've seen with the measurement tools, where they might not use the factors that we expected them to use. There are variations in scope. For instance, do we include or not the production of the hardware? And there is a huge temporal and geographical variability. So for instance, the carbon intensity of the electricity mix you use changes a lot between countries. So for instance, in France, it's around 100 grams of CO2 per kilowatt hours. And in the US, it's 5 times more. And it's also a huge temporal variability because if you have more wind, for instance, you are able to produce more renewable energy with also the solar panels if there's sun, etc. And depending on the time of the day, also there's less energy consumption, etc. So if we want to be able to reproduce to the final level, we need to account for this temporal and this geographical variability and report when and where the experiments were conducted. There has been different sets of rules that have been devised to improve the reproducibility of NLP experiments, and we can draw from them to improve the reproducibility of NLP carbon footprint assessments. For instance, if you do not follow rules on reporting the system metadata or the parameters of the tools you use, this might lead to crucial information for reproducibility not being reported. And if you have manual steps. So for instance, you need to copy the results from the estimation tool to a table, etc. You might have problems of inconsistencies of not the latest version that's presented in your manuscript. And what we could maybe do is define a standard for reporting the assessments. And for instance, we could ensure that all the parameters necessary to estimate with one specific tool, here the green algorithms tools, are properly reported with its versions, because the data also changes with the version of the tool. In conclusion, we can say that the environmental assessments are not easily reproducible and require special attention. In this work, we were able to produce the results of 3 out of the 5 studies using our tool, MLCA, which is a publicly available tool covering the production and usage of the hardware. It required a non-trivial information collection process, showing that there is still a lot of efforts required if we want all of the papers to be more reproducible. And it confirms the significance of hardware manufacturing impacts in large NLP experiments. In the Bloom case, it accounts for around a third of the impacts. So showing that we need to discuss what do we account for when we assess the environmental footprint. And I will end on that. It's really important to clearly define why do we pursue the assessments before pursuing them, because we will not use the same tools and we will not need the same levels of reproducibility, for instance, and even of understanding of the results, depending on what we do. If we are assessing only to have a reflexive thinking on what we can do to improve, we do not need it to be easily reproducible and so precise. But if we wanted to compare different models and to do proper accounting, we need it to be as reproducible as possible and as precise as possible. So clearly defining the objectives of the measures before doing them will also guide us on how to measure and what to evaluate. Thanks for your attention.
Thank you.